integration by partial fractions case 2, there are some repeated distinct linear factors. Take a look at the denominator. There are two distinct linear factors, x plus 1 and x plus 2. Which one is repeated? X plus 1, because it is raised to the second power, so it repeated twice. So how do we do the partial fractions in this case? So let's write the integrand. X squared plus x plus 1 divided by x plus 1 squared times x plus 2. So let's handle the x plus 1 first. So the x plus 1 is raised to the second power. So this is what we have to do. So we have to use A for x plus 1, and then we have to use B for x plus 1 squared. 1 for the first power, 1 for the second power. You must do this, right? And then the x plus 2, no repetition, just use one letter is enough. Okay, what if x plus 2 is raised to the second power? Then we need a c for x plus 2 and a d for x plus 2 squared. What if x plus 2 is raised to the third power? Then we need c for x plus 2, d for x plus 2 squared, and e for x plus 2 to the third power. So we need one letter for each power. Okay, and then look at the numerator. So we have x squared plus 1, x squared plus x plus 1, right? So for A, what is missing? So A, we have x plus 1. Look, I need one more x plus 1 to get a square. Look at the denominator on the left hand side. X plus 1 square, right? So in A, I only have one x plus 1. I need one more. So we need to multiply x plus 1. Also, we need to multiply x plus 2. And then for B, we already have the square, so we only need x plus 2. And then for C, we have x plus 2. We need x plus 1 square. All right? If you already watched the previous video, I taught a very convenient method to find A and B without using any system. So that method applies here. So this method, there is no name. You can call that try some convenient value. So let's try some convenient values. What convenient values? The first one is, what if x is equals to -1? So when x is equals to -1, do we agree that the factors x plus 1 will be equal to 0, right? And then you plug in x equals to -1 to the left hand side, you have -1 squared plus -1 plus 1. What about the right hand side? So once you plug in the x equals to -1, the x plus 1 will be gone. So the A and the C will be gone instantly. Then you have B times -1 plus 2. So on the left hand side, you have 1 equals to -1 plus 2 is 1. So you have 1 equals to B. We just got one letter. You don't need to expand anything. You don't have to group anything. And you don't have to solve any system if you use this method. And then the next one, what about x is equals to -2? When x is equals to -2, the x plus 2 is gone instantly, right? So -2 squared plus -2 plus 1, that is equals to, on the other side, no more A, no more B, because the -2 make them 0. So we have a C, and then -2 plus 1 square. So this is a 4 minus 2 plus 1, that is a 3. And then the other side, we have a -2 plus 1, -1 square is 1, so C, and then 3 is equals to C. We just got B and C. And then for A, look, you already use x equals to -1 to get rid of the x plus 1, and you use x equals to -2 to get rid of the x plus 2. It looks like you cannot use this method anymore. All right, then what do you do? So here, we will have to use the equating the coefficient to get another equation. I cannot try any more convenient value. The method is done, but I already have A and B. So this one, I would like to try something else. I would like to use equating the coefficient. Look here. the x square, the coefficient is 1, right? And then on the other side, how do you get the x square? You have to get x times x, right? So that means x times x and the a, there is a ax square. And then for the b, there is no x square in there. And then for the c, there is a c and an x square. Do we agree with that? So what is the coefficient of a times x times x? The coefficient is 1. This one you have to do a lot of thinking. For the a, let's do this again. On the left hand side, the coefficient of x squared is 1. Okay, on the right hand side of the equal, how do you get x squared? You have to do x times x, or you already have an x squared. So look at the a, the x plus 1 and the x plus 2. If you expand, do we agree that we have a times x times x? So that is ax squared, right? So we have a 1, and then we have a ax squared. And then for the c, do we agree that we will get a cx squared? Right? And then the plus. Do we need to worry about the other terms? The answer is no, because we only need to use the 1 for the x squared. For the x and the 1, we don't need them anymore. I only need to use one more equation to find a for me. So how do you do the equating the coefficient? What is the coefficient of x squared? On the left hand side is 1. What about the right hand side? The coefficient is a plus c if you factor out the x squared. But 1 equals to a plus c, you can solve it. You have 2 unknowns. No, that is not right. We have 1 unknown only. We already know c. So that is 1 equals to a plus 3. Then a is equals to 1 minus 3 equals to negative 2. I still got my a, b, and c without any system. Alright, so we got a, b, and c. What if you insist to use the system? If you insist to use the system, you have to fully open up the blue line and then use the equating the coefficient. You will get the same value. I'm not going to do that in this video. You can try that yourself. You will get the same a, b, and c. Alright, so let me jump straight to the integration. So we have integral from 0 to 1. 0 to 1, right? Or from 0 to 2. 0 to 1. And then the a is equals to negative 2. So we have negative 2 divided by x plus 1. That is just an ln. And then b is 1 divided by x plus 1 square dx, 0 to 1. And then c is 3 divided by x plus 2. So that is another ln from 0 to 1. And then for the first one, we have negative 2 ln absolute value of x plus 1. X goes from 0 to 1. And then the last one, we have 3 absolute ln absolute value x plus 2. X goes from 0 to 1. What about the middle? The middle, you have like the integral. So in the middle, you have integral x plus 1 to the negative 2 dx. Why don't you let u equals to x plus 1 and then du is equals to dx, right? So this is like integrating u to the negative 2 power, which is equals to, you bring the, this is like integrating u to the negative 2 du, so that is negative u to the negative 1. All right, so that means we have minus 1 divided by u, right? So u is x plus 1 and then raised to the negative 1. So that's why you put that in the denominator. X goes from 0 to 1. Okay, so we have negative 2 ln. Plug in the 1, you have ln 2. And then plug in the 0, you have minus minus, then that gives you a plus. ln 1, that will be 0 anyway. Minus, plug in a 1, so that will be a 1/2. Plug in a 0, that is 1, and then plus 3, ln 1 plus 2, and then 0 plus 2. Okay, can we simplify this? So the ln 1 is equals to 0, so ln 1 is equals to 0, and then we have negative 2 minus 3, so that gives me a negative 5 ln 2, and then plus 3 ln 3, and then minus negative 1/2, which is plus 1/2. All right, so that is the solution to the given integral. Alright, so that is the end of this video. If you think my instruction is helpful, I picked the best problem and gave you the best explanation ever, give me a like, give me a subscribe, share the video for me. I appreciate your help. See you all in the next one. Signing out for now.